All right, so multiple choice problems on practice exam 2. Let's go ahead and practice those and get them done. So what is the speed of the vehicle at the end of this time interval? For question number 1, we've got an acceleration a, time t, v equals at plus, and v naught is 0 because it starts from rest. So v is 4 times 5, which is 20 meters per second. The total distance the vehicle travels. So let's do x is 1/2 at squared plus v naught t plus x naught. These are all 0. So we have x is 1/2. The acceleration is 4. T is 5. We'll square that. So 4 times 25 is 100 divided by 2. That's 50 meters. Now here, a dart is used to fire a dart gun is used to fire 2 rubber darts, unknown masses. The gun exerts the same constant force in each dart, but the magnitude F is unknown, and the darts the magnitude of the acceleration is a1 and f1. What can we determine? Let's see. So we know F is m1 a1 and F is m2 a2. So the most we can do is set m1 a1 equal to m2 a2. So we can't get F. We can't get these. We can't get that, nor can we get that. We can really only get the ratio of m1 to m2 by taking the ratio of the acceleration. So we could do m1 over m2 is a2 over a1. That would be the only thing that we could get. All right, number 5. An object is thrown vertically upward in a region where g is constant, air resistance is negligible. We want to know the speed versus the time. So this is steady speed, steady non-zero speed. This is steady increasing speed. Ooh. This is the graph we want. We start off with a high speed, we wind up at a speed of 0. These are position graphs and they don't apply to the problem. Now, air resistance is negligible, 2 kilogram sphere, falls to a vertical displacement of 0.2, and we want to know its speed. So v squared is v naught squared plus 2a x minus x naught. So here we go. V squared is 0 squared plus 2. Acceleration is 10 times 0.2. V squared equals 4. So the speed is 2 meters per second. Wow. A person holds a portable fire extinguisher that ejects 1 kilogram of water per second at a speed of 6 meters per second. So check this out. It's not 1 kilogram, it's 1 kilogram per second. So when I actually multiply these two together, I get the units of newtons. So I get 6 times 1 is 6. All right, and then this one here. The velocity elevator, we want to know where the force exerted is the least. Well, force is mass times acceleration, and the acceleration is 0, right? Gives us the least force. So when does that happen? Well, the slope of the V graph is A, so we get a slope of 0, and the slope is 0 at 4 seconds. All right, so there's that. Object acceleration, sliding down an inclined plane. If n is a normal force, we want to know what the normal force is. This you need to, and we want to figure out which of these statements is correct. So let's be clear. There's no friction, so we've got mg. We've got the normal force. We've got mg sine theta, mg cos theta. All right, so we got mg sine theta is m times a, n minus mg cos theta, or n equals mg cos theta when we write down these equations. And so what we're left is the m's here cancel, so a is g sine theta. So that is the multiple choice section of the exam. All right.